Hi students. Good evening. Thanks for joining today. Today we will be going through chemistry exam strategies. Okay, so I think some of you joined me and my colleague for last week's practical. Okay, so thanks for joining us for today exam strategy. All right. So later teacher Ashikin will be joining again because we'll be joining a bit later. So because she has a class currently. Okay, so she will be doing the second part of this. Okay, without further ado, I'm going to start to share about exam strategies. Just give me a second. Okay, right. Now, so today's session will be sharing with you tips and strategies for tackling the O-level chemistry exam. Okay, so these are some things that you must know, okay, before your exam, and also what are the expectations for the exam, and what are the things that you should do beforehand. Okay, so it's great that all of you have joined. All right, so if you have any questions later, feel free to check with me. Just put in the chat and look at that. Okay, now I'm sure you know, right? Chemistry itself. Where to get this? Okay, today's a sharing session. All right, so the slides is not shared, but you can just take a screenshot as I talk, as I share here. Okay, yeah. So the slides will not be shared. Okay, but you can feel free to, because there's no materials to do, there's no work to do. Okay, but you just listen. You need to, if you want to, you just take a screenshot. Yeah, or take note and take down anything if you want to. All right. Right, so you must know that in this whole when you learn chemistry, right, in Sec 3, Sec 4, you might realize that okay, there are quite a number of things to remember. Remember your chemical bondings, remember your for Sec 4 electrochemistry, organic chemistry. There's quite a number of things to remember. But you must also understand that it's not all about memorizing. Science is not all about memorizing, be it chemistry, physics, or even biology. Okay, there are application questions. So whatever you know, you must apply them correctly. Okay, in exam, you will surely see unfamiliar context. No matter how many TYS questions you tried, there will sure be some new questions that you have not seen before. Okay? All right, so let's try to understand what chemistry is, what we're assessing you in the exam. All right, so that like I mentioned, first thing, okay, apart from knowing all the standard facts, definition, how to use instrument, what are the quantities like mole, okay, these are all facts that you have to know, okay? Which means that some of these you have to memorize, no choice. All right, because you'll be asked, because the exam is not all just application. Although I say application, there will be some questions which are more straightforward, needing you to define something, maybe defining relative atomic mass. That will just be 1 mark. Okay, but every mark is very important in your exam. Okay, so I understand that if you cannot answer some of these questions, then you might drop to A2. Okay, so you want to do your best, know as much as you can. Okay, be as well prepared as you can. Okay, so some examples like even standard ones may not be just memorizing. Okay, some techniques like getting the formulas right. Aluminum chlorate, 3, describe. These are common words that we are putting here. State, describe, explain. Okay, but they are very straightforward answers, and some of these you can kind of memorize the whole answer. Like for example, the third one. Explain in terms of arrangement of atoms why steel has a different have different physical properties to iron. Right? Steel is an alloy, iron is a pure metal. Okay, so for those who have learned the topic of metals, actually, if all of you are in if those in my structure, you have already learned this on alloys. Okay, so you have learned how to explain the difference in physical properties. Okay, so these are the more straightforward questions, what you call the knowledge understanding type of question. Okay, then of course there will be a number of application questions whereby there will be data, there will be experimental results, okay, and you need to apply whatever you know. There will be questions which are unfamiliar, so you have to try to analyze the question thoroughly and make use of whatever you know to answer them. Okay, especially for questions like database question. Later we'll talk about database questions. Okay, I'm sure some of you have doubts about database questions because you don't really do that kind of questions. Okay, for Sec 3, you may not even get to see database questions. Maybe a very small kind of question only. Okay, but Sec 4 students, you are more exposed to that. Okay. Okay, so these are possible types of questions where we use other type of command word like suggest. Okay, so it is not just writing long answers. Sometimes is you have to analyze the question a bit more. Then you can give a possible answer. Okay, or there are some things that you need to analyze in your setup in the diagram. Okay, then you will be able to tell the answer. Okay, calculate the change, etc. Okay, so these are different possible types of questions. All right. So you must know that there's a weightage for knowledge understanding questions. That's about 45. And out of that 45, 15% is just to recall. Okay, 15% is just to recall, meaning that just memorize something, relative atomic mass, or what's the ionic compound made of, things like that. Okay, and the rest of the paper, 55% on information and solving problems. Okay. Are there any combined science students here? May I know? You may raise your virtual hand. Oh, there are. Okay, great. Yeah, so whatever I mentioned applies also to combined science students, because chemistry, part of the combined science, is still the same thing. Okay, uh, just that for combined science, okay, later I'll talk more about that. But in terms of this weighting of the assessment objective, combined science students slightly different, 50% for each of these, but out of that 50% for knowledge and understanding, 20% goes to recall. Okay, that is just for you to know. All right, technically, if you study well for the exam, this one doesn't really matter. Okay, it's just for you to know what to expect. Okay, now in terms of format of the paper, okay, for Sec 4 students, definitely by now you have to know what your exam format is. Okay, you have paper 1 to 3. Paper 1 is MCQ, 40 minutes, 40 questions. Each question is 1 mark, and that is 1 hour. Okay, that means that each MCQ, 1.5 minutes max. Okay, if you can do faster, then of course do faster. All right, but you want to make sure that you have time for shading, have time for checking. Okay, now then for paper 2, the structure is written here. This is for paper 2. Okay, so section A, section B for paper 2. Now section A, 70 marks. Section B, 10 marks. Okay, out of that 70 marks in section A, last 2 questions are 20 marks. Okay, and one of them is a database question. Now, database question, they can be a shorter one, can be a longer one. So it could be 8 to 12 marks. Okay, so this is compulsory question you have to do. While section B is the one, they will give you 2 questions and you just need to answer 1. Okay, and that totals to 10 marks. All right. So this is the current exam format. Now, some students may ask, what happens if I do both questions? Then the examiner will just mark the first one they see, that's all. They are not going to mark both and then give you the one with that score higher. Okay, so they're going to mark the first one, or then they realize maybe that's the second one that you have done, but they will just ignore that. Okay, so that's how it works. All right, so just choose one. So now it's very clear, only in section B you choose. Last time it's not so clear, okay? The previous exam format is not so clear. Now only choose in section B. The rest in section A all must do. All right, then practical is a 20%. We talked about that last week. Okay, it is 1 hour, 50 minutes, 40 marks. Okay, now combined size different. Okay, combined size definitely different. Your multiple choice is split between the combined sizes. Okay, then for structured questions, structured and free response question, your paper 2, 3, and 4, they are 1 hour 15 minutes. Okay, the weighting is around 32.5%. Okay, in terms of the structure of that, it is still into section A and B. Same thing, section B, 2 questions, choose only 1. Okay, every question in section A must do, that's all. Last question, okay, they specify the last question is 10 marks, but ultimately it doesn't really matter. Just do all the questions in section A will do. Okay? Right. So in terms of syllabus, now you realize that both the pure and the combined chemistry shares the same overall overview of the topics. But what is mainly different, okay, I think maybe you already know, is in terms of depth, okay, in terms of breadth. How deep the topic goes, how deep it is, and how much concepts to learn. So pure, of course, more, combined will have less. But overall, the number of topics in total is about the same. Okay. Of course, we don't include like okay, organic chemistry is put as one whole big topic. Okay, but combined science have lesser lah. Okay. Now just to understand no, where you all are where you all are currently, maybe you just put in the chat which topic do you find the most difficult for you? Just put in the chats. I just want to know like what you all feel. Like especially for the Sec 4 students. Sec 3 students, maybe half of this you have not learned. For Sec 4 students, which one do you find most challenging? Calculations, okay, fair. I think calculations, uh, a lot of students have trouble with that. Electrolysis, organic, calculations, redox, okay. So now calculations 2, electrolysis 3. Okay, thanks for your responses. Okay, I think the standard ones, electrolysis, calculations, quite a lot. Okay, thanks for your responses. Okay, I'm seeing a few very common, difficult topics. I mean, topics that you find difficult in, which can also be difficult topics, I can understand, especially electrolysis, calculations. Okay, I believe most of you have learned calculations in Sec 3. But the thing is, it's just like mathematics. If you don't practice enough, then you'll forget. Okay, so it's really about time to bring it back. Okay, it's about time to bring it back. All right. So recently, I think my structure this week we are going through calculations. Right. For those who have not went for your classes, please make sure you try some of those questions. But I would say that one lesson is definitely not enough to bring back everything you need to know for calculations. Okay. So uh so you want to use whatever materials you have from the past, from last year, Sec 3. When you look through everything again, there are a lot of parts in your calculation topics. Okay, so please go and re-practice all those questions. Okay, electrolysis you only learn in Sec 4. All right, and I can understand it's very, very confusing. Okay, but some of the smaller topics I'm seeing here is energy changes, redox. Okay, energy changes and redox, I will say that these are the smaller topics that what we call the low-hanging fruits. You can actually score quite well for those easily. All right, so it's about how much effort you want to put in to really try to get things right. Okay, so if these are the topics that you currently feel you are facing difficulty in, try to no, it's not try, but you have to really start going into them and find out what is the gap. What are the gaps? If there are gaps, ask a teacher. Okay, we are already at National Day week already. Okay, we are not very far from the final exam. Okay, so please already start. I hope you have a plan. Okay, how you want to pace out your revision. Okay, so please have a revision plan and pace out all your subjects and topics. Okay, so this question is not half of the time is for me to know what topics you all find difficult in. Also, is for you to reflect what difficulties are you facing and are you doing something to it, okay, to make sure you do it right. Okay, so please go and do something to it. Okay, it's about time. Now, but just to list out all this, for all your reference, you can screenshot this. Okay, but just for you to know, right, some topics are quite heavily tested throughout the last few years, such as chemical bondings. Now, but then again, there's no guarantee. Whatever I put here is just analysis of the last few years paper. no guarantee that it's going to be heavily tested this year. Okay, like for example, I can say chemical bondings last out of 4 years, 3 years heavily tested, but maybe this year it's not heavily tested. No guarantee. Okay, like 2023 only 5 marks. All right, chemical calculations, which is what many of you were telling me you find this difficult. Okay, so it could be up to 10 marks. I would say average is around 10 to 11. Okay, so please put in some effort there. Now, acid, base, and salt, also a very important topic here. Electrolysis. You see, some of these topics, like what you all mentioned, are challenging, but it's also very common. Also have a high weighting in the exam. Okay. Now, organic chemistry at the bottom, wow, you see, it can, if I just roughly find the average, I would say this is around 16 around lah. Okay, I never calculate, just roughly. So it's around 16 marks. That's a lot of marks. Okay, but you also want to understand. Okay, hold on. You also need to know that for organic chemistry, right? The thing is, in the MCQ, you know how many organic chemistry questions there can be? Do you know? Have you all tried the TYS questions or other prelim paper? You roughly know how many organic questions are there in just the MCQ? A lot. Wow. You have tried the TYS already, Isan. Oh, okay. Yeah. Yeah. So what about the rest? What do you have you all seen the TYS? I hope you all have, right? Okay. Yeah, so there are actually quite a number. I calculated there to be rough average to be about 6 questions just for organic chem. Out of 40, 6 of them for organic chemistry. Because organic chemistry is a big topic, you must understand. You have alkenes, alcohol, carboxylic acid, and then you have polymers. Yeah, so 5 topics. If there are 6 MCQ, actually still acceptable lah. Okay, but you also need to know it's really quite a big topic. Okay, so please make sure you learn it well. Okay, okay, next. All right, so we'll go through some must know topics. Okay, why we call it must know? Because some of these topics really can be tested in any paper. Okay, what I mean by any paper, it can be paper 1, paper 2, of course. It could even be paper 3, like for example, okay, equations. Right, who knows? They may just ask you write equation for a practical. Okay, all right. So it is very important to be able to write equations correctly. Also, this week in my structure, we are covering the chemical equations. Okay, so you must one thing I tell my students is for chemical equations, you know what's the most important things for those in my class? You know what's the most important thing for your chemical equation? Or anyone can just answer this, of course. What is the most important thing for your chemical equation? No, no. No, 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 no. Okay, one of you said balance, one of you said state symbols balancing. No, these are not the most important thing. I can tell you, these are not the most important. Any other answers? Charge? No. I mean, then okay, charge maybe. Swapping of formulas. What do you mean by swapping of formula? Do you mean like forming the formula? Swapping the charges? Getting the reagents and products correct. Oh, okay, Austin. I think you make a point. Austin, getting the reagents and products correct. Okay. Yeah, that is also important. Yes. Okay, maybe I put this before mine, which I thought is the most important. Okay. Must write in one full line. Yeah. If there's really no space, then it's then you have no choice. Like may not have to write in one full line. Uh, Swapping the formulas. Oh, you mean like the ions switch places to form the product, right? Okay, no, that's not what I meant. which I think what I combine yours with Austin's answer, getting the reagents and products correct. Okay, maybe that is the most important. Like for example, they give you acid and metal. Then of course, yes, first thing you must know what are the products, what are the types of products. So which means that you must know the reaction. You must know that that is an acid metal reaction, and what are you supposed to get? Acid metal, right? So salt and give me an answer, salt and okay, no answers. Okay, hydrogen. Very good. Thank you, Yusan. Yeah, salt and hydrogen. So you must at least know the type of products. And then, okay, then the second thing is your correct product. Okay, depending on what acid and what metal you have used. Okay, so that may be the first thing. But what I wanted to say that is the most important is the chemical formula. Do you know your chemical formulas well? Do you know how to form your chemical formulas for ionic compounds, for covalent compounds? The problem is, right, many students cannot even write chemical formulas. Even at Sec 4 level, some students don't even know the charge of magnesium ion. That is a big, big problem. Okay, for example, simple ones like what's the formula for magnesium chloride? So when you write your equation, if you write magnesium chloride, okay, chemical formula, that's my answer. If you write your formula as MgCl, then no matter what you write, no matter how you balance the equation, it's going to be wrong. Doesn't matter you spend how long, you spend 10 minutes, your formula is wrong, it's wrong. No saving of that. There's no saving of your marks here. So it is very important your chemical formulas are accurate. So this is wrong, it's MgCl2. Okay? So let me give you a quick question here. What about ammonium sulfate? Can anyone write the formula for ammonium sulfate? Just a quick test. Great, thanks for your responses. Okay, yeah, so I'm seeing some wrong answers. Ammonium sulfate. Ammonium sulfate. Okay, great. Yeah. Okay, so I'm seeing a few answers. Let me just write down some of the wrong answers here. So I'm seeing NH4SO4. I'm also seeing NH3 bracket 2SO4. Now, so all these are errors. I'm also seeing this NH4 bracket 2 bracket SO4. Now, all these are not correct. Okay, now let's write the ions first. So ammonium ion NH4 plus, sulfate ion SO4 charge 2 minus. Okay, so compare these two. I need how many ammonium ions? How many ammonium ions do I need? Two, right? I need to balance the charge. Sulfate is 2 minus, but ammonium is plus. So I need two ammonium ions. So because ammonia is polyatomic, you put a bracket 2. Okay? So that you can see 2 here. Then sulfate, we just leave it alone. SO4. That's all. This is the answer. Okay? This is the answer. Alright? Can so like I said, okay, I'm going to move on already. What I want to put here, what I wanted to emphasize here is chemical formulas, very important. Make sure you get it right. Okay, next. Okay, calculations are then, okay, so all of you must know your formulas very well. All these formulas are not provided in the exam. Okay, you are only given periodic table, the basic periodic table, nothing else. Not the mass structure periodic table. Okay, so all these formulas are not provided. you must know if the question give you mass, you must make sure you change it to grams. If they give you volume of gas, make sure you change to dm cube. How to change to dm cube? You divide the cm cube by 1,000. Okay? If they give you mass in ton, right, then you multiply by 1,000,000. Okay? Now, but a lot of students make this mistake. A lot of students make this mistake. They see like volume in the question, and they use that volume to divide by 24 dm cube. Sounds correct, but that volume belongs to a solution. Okay? You only can divide by 24 dm cube if it is a gas. Okay? So all these are important uh things that you must remember. Okay, so you must go and practice a lot on calculations. If you are facing difficulty in calculations, you have to go deep into it. Okay, and I can tell you it can be done. Okay, you practice a few times, you will get it. Okay, don't give up on the calculations because calculations really they can test you everywhere, especially practical. Because you have titration, if you have titration, then there will be titration volumetric analysis. You need to do your calculations. Okay, so calculation is something that you must master. Okay, and of course, not to say paper one and paper two, from will come out. Okay, next. Trends and series. Okay, so you must know the trends. Okay, with some of these things you have to remember, have to memorize. Okay, trends for your group 1, group 17, reactivity series, electrochemical series for pure chemistry. So all these are things that you have to know. Okay, I will not talk too much about this. Dot and cross drawing. These are things that are not too difficult. Okay, because there are more difficult things to remember. Electrolysis, organic chemistry. These are things that are more difficult. Okay, so the easier topics, the low-hanging fruits, please get them right. Especially if they give you a chemical warning questions and ask you to draw just a simple ionic compound or covalent compound. Okay, but you also want to practice on those polyatomic ions like hydroxide, carbonates. These are very commonly seen exam questions, which is a bit more difficult to understand. Okay? And for those who have done the Sec 4 prelim mass structure paper, you know what I'm talking about. Okay, you have seen that question. All right. Now, one thing to take notes for dot and cross diagram. Now, you have to try to use different symbols to show the electron gain. Okay, so you see there's an error here. That's why I put a cross here. It's an error here, right? Because the oxygen is the charge is 2 minus, it gained electrons. Okay, so you cannot draw all crosses. It has to be 2 dots. Now, these 2 dots must be separated also. That's another point. These 2 dots must be separated. You cannot draw them pair up together. Okay, because oxygen as an atom looks like this. All right, these 2 electrons are split. They're not together. So any electrons that are gained should just fill up the gap. Okay? Understand? Any questions, just put in the chat, huh? So I'm going to move on. Okay. Now, for dot and cross diagrams, okay, some things you must know is, especially for covalent compound, I think ionic compounds are quite straightforward, but covalent, maybe some of you might find some difficulties trying to draw it correctly. Okay, so you must know that if an atom has 7 valence electrons, and then it only needs to form one bond, one covalent bond. Okay, if the number of valence electrons is 6, okay, then it needs to form 2 covalent bonds. Okay, anyone of you learn this term valency in school? Do you all learn valency in school? Not really. I think some of you learn valency. Now, so valency is a similar concept. Valency basically measures it is like the combining capacity of an element. Okay, which means that it measures how much the atom can bond with other atoms. That's a simple way to put it. Okay, how much it can bond, which means that if the valency is 1, then it just needs to bond 1. Valency is 2, then it needs to bond 2. Okay, so for those in group 2 and group 16, then their valency is like 2 lah. Okay, so they need to either lose 2 electrons or share 2 electrons. Okay, but if you have not learned valency, it's fine. Okay, so just use whatever method you are very familiar and make sure you can get this covalent bonding correct. Okay. Now, other things to take note. Energy profile diagram and energy level diagram. Now, this is under the topic of energy changes, and just now some of you mentioned energy changes you find difficult. Okay, so this is one thing that I want to highlight to you. Now, energy profile diagram is the one that has the activation energy. Okay, the mountain. Right, energy level diagram just shows you the different levels. The energy level of reactants, energy level of product. Okay, while the energy profile diagram, it shows you the activation energy as well. Okay, now you want to take note of all these arrows that you draw. Okay, all these arrows that you draw. Now, these arrows, they always start from the energy level of reactants. Okay, if you are still not sure how to draw this, which I've seen many students do not know how to draw this. Okay, especially like when it's endothermic. Okay, let me just draw one endothermic one. Endothermic, right? Endothermic is like that. Now I have seen many of my students in the prelim exam. The activation energy, is where? Many students draw here, which is wrong. All the energy levels, all the arrows always start from the reactants. The energy level of the reactants. Okay, so this is wrong. All right, major mistake, very common mistake, but students are still making it. Okay, so please make sure you don't make this careless mistake. Always double check. All of them start from the same level. Okay, energy level of the reactants. All right. Okay, and all the arrows are single-headed. Oh, another common error I've seen is the arrows drawn wrong direction. If it's exothermic, some students draw upwards. Okay, so everything starts from the energy level of reactants, and finally, if the product is lower, so draw downward. If the product is higher, you can draw upwards. Okay, starting from energy level of reactants. All right, so go ahead and go through some of these concepts again. Okay, now test for gases, cations, anions, redox, oxidizing and reducing agents, or even distinguishing tests between saturated and unsaturated organic compounds, hydrocarbons, okay, or even tests between alcohols and carboxylic acid. All right, so I think all these tests are very important, especially the QA part. Okay, I will say QA. Remember, you have to know for your practical, but like I said last week, okay, is some of the observations are given in the question paper itself. Okay, so you don't have to be memorize so much for the practical, but by then it's already very late. You have to already know it for your theory as well. Okay, so make sure you already have some ways to try to remember these results. All right. Test for oxidizing reducing agent. Okay, we are using the common oxidizing and reducing agents. Okay, so all those you must know. Okay, distinguishing test for alkenes or unsaturated compounds. Okay, we always use aqueous bromine. You also want to remember, right? First four members of alkane and alkenes. I hope all of you have heard this before. First four members of alkane and alkenes are gases. Okay, for example, methane, ethane, propane, butane. They are all gases. And if you want to test for unsaturation, you bubble these gases into aqueous bromine. Okay, because you add a gas into the aqueous solution instead of you adding an aqueous solution into a gas. That don't work so well. Okay, so you bubble the gas directly into the aqueous bromine. That is the correct method. Okay, so you want to bubble these gases, huh? All right. So some of these tests, please go and take note. Now, what I mentioned here, Cu2 plus ion is named as copper 2 ion. Okay, just something to take note when some of you write your answers. Okay, you need to, if it's a transition method, you need to include the Roman numeral. Okay, especially if you're calling it by ions. It's copper 2 ions, not just copper ions. Okay, or some of you, when it's just copper metal, you leave it as copper 2 or iron 2, iron 3, when it is just a copper metal atom. Okay, so those are times where you don't include the Roman numeral because it's just an atom, it's not even an ion. So there are no oxidation states or there's no charge. Okay, so I'm mentioning some things for you to take note of in this part. Okay, now just to give you a quick test, this is actually a 2023 question on QA. Now, this is an actual question for O-level. So name one reagent which is required in each test to identify the ions in the product. Okay, of course, we are not doing the whole question. So what we want to do is just to test for a particular ion. Now, so when you're asked to describe how to carry out, describe how, now then your description must be a bit more detailed. Okay, many of you might just write, oh, add a few drops of aqueous sodium hydroxide, then in excess. Now you may have forgotten the first part here. We have to start from start. You need to have the solution in the test tube first. Okay, so you can add about 1 cm cube, add about 2 cm cube into the test tube. Yeah, that's the first thing before you add your aqueous sodium hydroxide or your aqueous ammonia. Okay, but in this case, if we are adding sodium hydroxide, then if a white precipitate is soluble in excess, what is this ion? Yes, correct. Nylene, if I pronounce your name correct. Nylene, yes, correct. Aluminium or zinc ions. Okay, yeah, Zn2 plus or Al3 plus, correct. Okay, it's time to answer your question. So no need write oxidation state when not ion. Yes, correct. Yeah, correct. So for example, if it's just iron metal, like iron, let's say iron plus acid, let's say hydrochloric acid. Okay, I just put HCl. So when you're supposed to write chemical equations, right, you just write Fe plus HCl. So this Fe is just iron. This is not iron 2. Right, because when you write 2, it means that the oxidation state of this iron is 2, but it's not. It's 0. It's just the atom of iron. So oxidation state is 0, so there's no need to write this. That is what I meant. Okay? Only in the compound, then you will have this oxidation state. Understand? Yeah, okay, yeah, so I think some of you have answered the question. So this is aluminum ion. So if it's aluminum ion, then it's either Al3 plus or Zn2 plus. Okay, great. So you know your QA. So please find some ways to remember your QA. Now, if you have received the mass structure periodic table before, you have seen we have some tick tick cross cross pattern. Try to remember that pattern. It may help you. Okay. So it can become a muscle memory. Now, so apart from what I have mentioned just now, there are really some topics where there are fixed answers or standard answers. I think the very common one, really chemical bondings. This is like what you learn in Sec 3, and a lot of it is memorizing. But of course, it's not just memorizing. Mostly it's memorizing, but when they give you a question which is very free response or open-ended, then you have to learn how to phrase your answers correctly. Okay? Because they can give you this question in for example, section B. of the paper two. Okay, for pure chem lah. Okay, so then they can just give you 5 marks just for you to write an essay on chemical bonding. They ask you to compare different substances, in terms of their melting point, in terms of their electrical conductivity, and you just freestyle, write it on your own. They give you an entire page to write that. Okay, so you must be able to remember correctly, then phrase your answer or compare correctly. Okay, coming back to this, how come nobody's giving me the answer? Can I have the answer? Yes. Okay, so these are really important concepts. Oh no, why am I saying wrong answers? Okay, for those who give me the wrong answer, you have to take notes. Okay, chemical bondings all Sec 3, Sec 4 have learned. Okay, so there's no reason for you not to know this. Alright. So sodium chloride. First thing, ask yourself, is sodium chloride ionic or covalent? Sodium is a metal, chlorine is a non-metal. So this equals to ionic compound. And ionic compounds, when it is aqueous, it can conduct electricity because of free moving ions. No electrons are involved here, so nothing about the electrons. The electrons are already part of the ions, right? Because the electrons are transferred from the metal to the non-metal. So the electrons are not free moving. Only the ions are free moving. Okay? Where still I see some of you put 4. There are no molecules. Molecules are for covalent. But we are talking about ionic. Okay, so our answer is 3. Okay, so please get it right. Okay, these are low-hanging fruits, just to make sure you know. Okay, these are the type of questions that they can give you and give you a number of marks. 3, maybe this one may be 3 to 4 marks. Okay, explain in terms of bonding and structure. I would say this is a very common type of question, and you see in most tests to compare between two substances, be it melting point, be it electrical conductivity. They can test you on diamond, graphite as well. Okay. All right. I don't need you to answer this question. I just want to show you how you can structure your answer. Okay. So in most of the time when you explain, please do both. Even if the question don't say anything, like in terms of bonding and structure, just write. Nobody can fault you if you write correctly. Of course, if you write wrongly, then I cannot help you lah. Okay. So please always include structure and bonding, but they have to be accurate also. All right, so how can you explain this question? How can you answer this question? Now we are given hydrogen chloride, we are given sodium chloride. Now you must understand that hydrogen chloride is a covalent molecule. It is not hydrochloric acid. That is very important. Hydrochloric acid is when hydrogen chloride has dissolved in water. Then it forms the acid. So before it even forms acid, it exists as hydrogen chloride gas. Okay, so which means that this is a simple molecular structure. And of course, it's different from sodium chloride, which is giant ionic lattice structure. Okay, so in terms of bonding and structure, first thing you must talk about, okay, one way is to talk about each of them by themselves. For example, I think most of you might be writing something like this. Hydrogen chloride has this structure, simple molecular structure. You need a small amount of energy to overcome weak intermolecular force of attraction between molecules. Done. Just on hydrogen chloride, one full sentence. No. Hydrogen chloride is not giant covalent. Okay, hydrogen chloride is has a simple molecular structure. Okay. Wait, again, okay, I repeat again. So hydrogen chloride is just a simple molecular structure, right? It is just between hydrogen and chlorine. It's a simple molecular structure. Okay, so you only need a small amount of energy to overcome the weak intermolecular force of attraction. So there are a few things, right? The structure, simple molecular structure. Bonding, weak intermolecular force of attraction between the molecules. So all this must be written. And then the last thing, talk about how much energy you need, small. So all this must be accurate, the structure, the bonding, and energy needed. In terms of sodium chloride, giant ionic lattice structure, a lot of energy, overcome strong electrostatic force of attraction between the oppositely charged ions or sodium and chloride ions. Three main things are structure, energy, bonding. Okay, now this is one way to write your answer. You just focus on one each. Just focus on each substance. Hydrogen chloride first, then sodium chloride. Or if you want to write it differently, which some of you uh have tried before, you can compare the structure first, then you use comparative terms, such as less energy needed to overcome the weak intermolecular force of attraction. Basically, everything is still there, but phrased differently. Okay, so less energy needed to overcome the weak, then the strong, Everything is still there, but phrased differently. Either one is totally fine. One is slightly shorter, but you must know how to structure your answers. Okay? Then done already. Oh, can't you, I need to hurry up. Okay. Okay, I move on already, Right. Now, speed of reaction is another topic that is really a lot of standard answers. Alright, if you have learned this topic, Sec 4 should have learned already. Sec 3 depends on your school. Some of my Sec 3 students have learned this also. Right. One thing that a lot of students always forget in your answer, especially for catalyst and temperature, is this part that I've highlighted in red. More particles have energy that is equal to or greater than activation energy of the reaction. A lot of students will always miss this. No matter how many times you try the questions, you will miss this sentence. That costs you 1 mark, unfortunately. Okay? But I just want to highlight that for speed of reaction, if you're asked to explain why speed of reaction is faster, it's really standard answers. Please go and memorize those. Okay? Move on. Okay, other things like salt, your preparation of salt, how to describe precipitation, your reaction of acid, your titration. Again, these are standard answers. Redox, why is a reaction redox? All the standard answers. Okay, so please go through them again and again. Write it a few times, become muscle memory. Okay? Others like reactivity series, energy changes. Why is it exothermic or endothermic? Kinetic particle theory, you have learned this since Sec 1. Really, all these are standard ones. Okay? Please go through them and get full marks for these topics if they come out. Okay, now just one thing on redox. Very important mistake that student make is this part. Okay, the main difference here, oxidation state of what? Oxidation state of what? Oxidation state of what? I think this is the main difference here. Which one is the correct one? Okay, thanks for your answers. Okay, I'm seeing 3, I'm seeing 2. Okay, I think most of you got it correct. It's 2. Okay, it's 2. So when you talk about oxidation state, it's of that particular element, not the ion in the compound or what, just the elements. Okay? Because it may not be an ionic compound. It could just be the ion itself. So oxidation state of ion. Okay? So never write the compound itself. That's definitely wrong. Never write the ion. This is the correct one. Okay, so 2 is correct. And I'll move on. Okay, now sharing with you some tips and strategies for improvement. Okay, now some of you might be struggling at this moment. Okay, I hope you have already started some revision. Okay, at this point of time, for Sec 4 especially, you have finished mass structure prelims. Okay, You're most likely going to start your prelim in school already soon, around this period or next week. What you need to really do is go and make sure you identify the topics that you are weak in. You may use your last year paper, end of year paper, try to master a Sec 3 topic first. If Sec 4 topics you really cannot, okay, focus on Sec 3 topic first. At least, you take all the low-hanging fruits first. Sec 3, easier. Okay, master those. Okay, and you have mid-year, your WA2, go and see what you need help with. Okay, next, some students make their own notes. Some students make their own notes. So I don't know what is your study habits. Okay, if making notes is your thing, do it. Okay, if since Sec 1 you have been making your own notes, do it. Right? Because sometimes when you write it out, and then you actually learn faster. Okay, so everyone has their own different studying method. If you want to draw mind map, it's up to you. You want to write summary notes, it's up to you. If you don't want to write any of those, you just refer to my structure notes or your school notes. Totally fine. Okay, find the method that works for you. Okay, and make sure you go and look at some of the keywords, phrases, the standard answers. Please go through them. Okay, and try to master by topic. Okay, you don't have much time to your prelim and O levels exam, so at this moment, if your topics are still not strong, that is the first thing you want to do. Don't go and do that whole time exam paper first because you have not even mastered the topics. Okay, so do that. Practice topically. Make sure you master topic by topic. Like some of you said, you have problem with calculations. Make sure you go and tackle that. You have trouble with electrolysis. Why have you not done something about that? Okay, so do that. Once you have done that, then you go and start doing the test paper. Okay. But as you all do, you see the correction and all, write down some of these things that you find that you still have trouble understanding. Then go and consult your teachers. Don't wait till the last minute. Okay? It's about time for you to find out what gaps you have and go and ask. If you don't ask, you'll never improve. Okay? So go and ask. And if there anything that you find that you always get wrong, note it down also. You want to find a small notebook or the regular or your digital device, just note somewhere for your quick revision. These are the things that I always make mistake. Then before exam, just go through the list. Okay, do I know the formula? Is my formula correct or not? Okay, or is my freezing? What's wrong with my freezing all the time? Yeah, go and put it down and just go do a quick revision before your exam. Okay, so this is just one way to organize your notes if you want to make your own notes. Okay, like for example, I want to do the different chemical things, right? Different structure. Go and write down a few things: the structure, the melting boiling point, electrical conductivity, and so on. Okay, this is just for you to see how you can do your own revision notes. Okay, but of course you can screenshot now if you want to, but I don't have the notes for the electrical conductivity. You can fill it up on your own. Okay. Organic chemistry, okay, can be something like this, but of course, don't have to be like this. You can screenshot this. This should be for most of the concepts that you need to know. Otherwise, you can write your own notes. Okay, screenshot this. I give you 5 seconds. Otherwise, it's gone already. Okay. This is an example of a student's handwritten organic chemistry notes. It can be a bit messy here and there, but it's really her own notes. And I think when she read it herself, she learned it better. Okay? So this is something that you can write. Okay, that you can do like that's for reference. Okay, it's very small, you can't see anything else anyway from the screen. Okay, just an example. Okay, the same students. All right. Now, a few more things before I pass the time to teacher Ashikin. Now, another topic that some of you find difficult in is really electrolysis. Electrolysis can be a bit confusing, honestly speaking. Okay, so you must go through the fundamentals first. Okay, go through step by step. There's a step-by-step process to understand electrolysis. Okay, like for example, if it's electrolytic cell with the batteries, you always start with the terminals of the battery. So that makes this the positive electrode. So positive electrode means it's the anode. So step-by-step process. You go through that process a few times, you get the hang of it, you will have a better understanding, or you can do the questions better. Okay, so practice on that. Okay, go through that process diligently, you get it. Okay, you may not, eventually, right, I can tell you, you may not fully understand electrolysis. It's fine. It's all about uh going through that thought process, knowing the habits, the method, the technique to get the answer. If at the end of O-level exam, you don't know how, you still don't understand fully, is the reality lah. Most students don't fully understand. It's okay. It's about getting your scores. Okay, as long as you know the method, you know the way to get the marks, then you have done already. Okay, that's the best result already. Okay, and okay, just a few more. Okay. Oh no, I got database questions. Look at the time. Okay, 8:30. All right. Okay. I think just giving you some tips. I think paper one, paper two, these techniques I think is very common. You all should already know since PSLE. Okay. One thing is the time management. Okay, time management. You must know how much time you should allocate for each question. At most 1.5 minutes. Okay. If you cannot skip first, come back later. You might have time. But always try to share your answer immediately after completing a question. Okay? Because what you need to know is, you want to avoid shading error. You have 40 questions. Imagine you shade one wrong at question 5. That's it. You have to erase 30 questions. The world is ending. Okay? The sky is collapsing. Okay? So try to do one, shade one. Okay? And don't panic. Okay? Do it one by one. Okay? And if you're unsure, do elimination method. Okay? I think these techniques you all should know. You all are Sec 3, Sec 4 already. Okay? Open-ended questions are your structured questions. Okay, the standard ones. Please make sure you read the command words. What do they want you to do? Okay, very common mistake is, I think it's always the describe and explain. When they ask you to describe the steps for your experiment, you go and explain. Okay, you describe already, then maybe you explain why I do that. Don't waste the extra time. They are not marking you for the explanation. They just want to see your steps. So you waste the extra time. That time can be spent writing another answer. Okay, so please make sure you look at what is required for the question. If you have a lot of marks for that question, 3 to 5 marks, for example, those section B questions where you choose only do one question out of two, right? Usually those questions they might give you 5 marks questions. Okay, so that's why you need to plan, like the chemical bonding question. They give you sodium chloride compared to hydrogen chloride. How are you going to structure your answers? How do you want to write it? You have to plan it out. Sometimes it's more than that. They ask you to compare between 3 or 4 substances. Then that is really complicated. You have to plan it out. Okay? If you've seen those O-level papers, you will know what I'm talking about. Okay? They came out before the last few years. Okay, coming to database questions. Now, database question, I think, is one of the kind of questions which you don't have much experience with. Okay, you may have even more experience with practical than database questions, maybe. Okay, or about the same, right? Because you don't get much exposure. Now, database question, you need to spend time going through the information. It can be something like comprehension, try to understand what they're trying to say. So what you need to do is read all the info, don't skip anything. You need to highlight anything, circle anything, do that. Okay? There might be graphs, there might be table, go through everything. But maybe if there are graph and table, okay, you may not have to go in detail first. You also want to read the questions. See what the question wants you to look for. And then you come back and look at the graph and table. Okay, because sometimes that makes more sense. If you feel that, okay, I read the question first, then I know what the question is looking for, I need to focus on the graph, okay, then you go to the graph. Okay, so see what the question wants you to do. Okay, now the thing about database question is you don't know what they are going to come out. Okay, of course, I mean, you don't know what they are really going to come out for exam. But I'm just going to show you like what has came out before. You may want to take a screenshot of this if you want to. Database question remind you 8 to 12 marks. Okay, these are the topics that came out before. Whether they come out again, okay, they are unlikely to repeat, but we never say never. Okay, I think there are some connections between some of these topics. Okay, but this is just for reference. I cannot guarantee what may come out next, but I can give you some prediction. Whether it really comes out or not, I would say it doesn't really matter so much. I'm just showing you some possibility. But you can see just from the current few years, right? The recent years, what do you notice? Let's say the most recent one, carbon capture, uh, fuel, flue gas desulfurization, fuel, ethanol. This is biofuel. What do you see? Okay, organic chemistry. A lot of focus on organic chemistry just in the last 4 years, 2022 to 2025. Okay, a lot of focus on organic chemistry. But not just that, also in terms of green chemistry. You know what is green chemistry? Green chemistry means in terms of issues like pollution, climate change, sustainability, things like that. Okay, like for example, this ethanol is bioethanol, is biofuel, and that is already towards sustainability. Carbon capture, all right, all these are towards issues that humans are facing nowadays. But again, there's no guarantee, no guarantee. Okay, don't quote Mr. Chu here. Okay, but I'm just going to show you these are the trends that we observed. Organic chemistry, some of you mentioned this. Okay, it dominates the recent ones, but there's no saying that they're going to do that again. Nobody says that. Okay, green chemistry in terms of climate change, etc. Okay, which I mentioned already. All right, and you can see, last time it was a lot more on small experiments like tests for the metal, etc. Okay, but nowadays it's a bit more on industrial processes. Okay. Last time they also have concepts on bleaching, de-icers. Okay, if you have done your 10-year series and you have seen all these questions, right, you'll find them familiar. 2020, right, is still pretty close, 6 years ago. Okay, so it's still inside. All right. So these are different types of topics that have come out before. What have not really come out in the recent years is okay, maybe yes, have not really come in the recent years, electrochemistry. I think electrolysis have disappeared for a while for database. Last one was 2012 lah. Not that far, not that far. They might come back. Metals, reactivity. Okay. Rate of reaction, they hardly test that, but who knows? Okay, these are just things for you to take note. Periodic trends. Last time it was tested in 2013. It's quite recent also. And not say very recent, but okay, I think I got my years wrong. These are not very recent. These are a long time ago. Now it's 2026 already. Why I thought this was 2022. These are more than 10 years ago. Okay, very old. Who knows, they may come out. Okay, so these are possible type of questions that may come out. Okay, again, no guarantee. What is relatable electrochemistry? Organic might come out again. Sustainable materials like plastic. Now, actually, some of these you have seen before in our MyStructure questions. Biopolymer like PLA. PLA, you might find it very familiar compared to addition polymer, your polyethylene. As we have seen all this in our paper 2 questions. Okay. Rate of reaction, like we mentioned just now. Or it could be something that on green chemistry or relating to environment. Who knows? Okay, some of these might appear. Okay. Now, so the thing about database question is, okay, there is really no need to go and spot anything. You may go and try, okay, please go and try, not me, you please go and try all the database question that you can get, especially TYS, prelim papers, go and try everything. Or if you don't want to try all the other papers, it's okay. Try the database questions from the different schools. Okay, they will help. Not in terms of maybe the same question will come out, but in terms of getting you ready for the database question. Because the thing is, probably the same question will not come out. Okay, but it's to really prepare you because everything is going to be unfamiliar. It's going to be a question you have not seen before. Okay? But don't panic. Don't need to memorize anything specifically for that. But I mean, overall, paper 1, paper 2, you still must memorize lah. Just that, not for the database question. It's all about testing you on data analysis, on your observation skills, reading the passage, extracting information. These are the more important skills that they are testing you for database questions. Okay, they can test you on something out of syllabus, surely, but they will give you sufficient information for you to answer your questions. Okay? So use whatever you know, all your learned concepts, and answer the questions as much as you know. Should we time our, okay, one of you asked, should we time ourselves when practicing database question and how long? Okay, just now I have given a rough time duration around 20 minutes. Okay, but also want to take note that database questions are only 8 to 12 marks. So again, okay, you must know again, just like I mentioned at the start, right? Database question is the last question in section A. If let's say you are really scared of database question, okay, don't worry. Maybe you want to do it as the last one, which means that you finish all the other questions in section A, then you choose your question in section B first, finish all those, come back to database as the last one, 8 to 12 marks. You see how much time you have left. Okay, but that is just one method. But if you're confident, you see the database question looks okay, manageable, okay, just do it. Okay, just do it. So around 20 minutes for that 8 to 12 marks. Around, okay? You may spend less or try not to spend more than 20 minutes because you have a lot of questions to do. Okay? That's our recommendation. Okay, this is my last slide. Okay, so like I mentioned just now, important thing is master the topic first, okay, before you try all the timed papers. Okay, timed paper means that you do it within that 1 hour 45 minutes for paper 2 or 1 hour for your paper 1. Okay, you want to master the topic first, then do the rest. Okay, then time yourself. Okay, like I said, do all the database question, TYS, prelim papers, do it. Get enough exposure, train yourself, be ready for the unexpected. All right? Okay, I pass the time to teacher Ashikin. Thank you. I can't hear you actually. Okay, while waiting for teacher Ashikin, if you have any questions, please put, okay, is database question for section A, B, or C? No section C, Kaden. No section C. Database question is in paper 2, section A. Do you miss the first part? You came late, is it, Kaden?
Hey, hello.
Yeah, can hear you now.
Okay. All right. Okay.
Yeah.
But is it clear?
Yeah, now it's better. Just now a bit soft.
Oh, sorry. Sorry. There's something wrong with my microphone on my laptop. I'm so sorry. Okay. Right. So, like what Mr. Chu had mentioned, okay, I hope you guys have a better understanding of how to approach your exams. Okay. Now, I will be talking about how you can approach a practical paper for both pure chem and also combined science. Okay. For pure chem, remember it's paper 3, whereas combined science is paper 5. Okay. Right. Next. For practical, for pure chemistry, the weightage of marks is that, okay, so for 85% of your marks in practical paper is based on manipulation of data, measurement, observation, and how you present your data and observations, and also how you analyze and make conclusions and also evaluate the experiments given to you. And 15% of it comes from planning, okay? So please be very careful with planning. I know 15% doesn't look like much, but it can also pull your marks up, okay, if you do really well, right? Okay, now, so for combined science, practical paper 5, right? You need to answer for physics, it's 1 or 2 compulsory questions on physics. Same for chemistry, 1 or 2 compulsory questions. And in one of both questions, you are expected to suggest a modification or extension that does not need to be carried out. Okay, next. For skills in experimental skills and investigation, first you need to look at the sequence of instructions. Of course, you have to look at the instructions. If you don't read the instructions, then you can't answer the questions, correct? Okay, so that's one. Okay, and then select and use techniques, apparatus, and materials. Okay, you must use the correct apparatus. So for example, you want let's say the experiment asks you to measure the amount of, rather the mass of a certain powder. Okay, let's say magnesium powder. You don't use burette, right? You have to use weighing balance, right? Okay, so next, make and record observations, measurements, and estimates. If they ask you to draw a table, write down a table and record observations, you need to do so. I'm so sorry, they're screaming at the back. I'm sorry, okay? Record observations, measurements, and estimations, okay? And next is interpretation and evaluate observations and experimental results, okay? Oh, should we time ourselves when practicing database questions and how long? Mr. Chu, would you like to answer this? I'm so sorry.
Oh, this one I answered just now already.
Oh, okay, I'm so sorry. Okay, all right, sorry. Okay, so now next, okay. So interpret and evaluate observations and experimental results as well. And also you need to plan investigations, select techniques. Okay, when it comes to planning of investigation, right, you need to look at what is your hypothesis. You have to make out the hypothesis. What are you testing? What is the question asking you? Are they testing for something like whether the amount of sunlight will, will turn, or sorry, will make the, what do you call that? Not say convert, but in terms of the amount of UV radiation, will it affect the rate of which substitution reaction in organic chem, of especially alkanes, right? So we need to look at that. What are you looking at? Okay, what are you investigating? And also the techniques and apparatus and materials also very important. Okay, you need to use the right apparatus, materials, and also the techniques that is applicable for that particular investigation. Okay, then next is evaluate methods and suggest possible improvements. Okay, so from what we all know, right, when you do experiment, right, when it comes to improvements, you will never blame yourself. You always blame how the things, the apparatus works, whether it is how you can make it better. Never you, never your fault. Okay, so that's one of the take that we have lah. So of course you have to look at how you can improve your apparatus that you use. Okay, from measuring cylinder, you can actually use how to improve the experiment. Let's say your experiment, you use measuring cylinder, and how to improve the accuracy, right, of the volume. You can always use burette or pipette. Okay, so that's what I'm talking about when I say possible improvements. Okay, next. So let's look at tips and strategies. So first, you need to read the question, okay? Never read the question, then cannot answer the question, definitely, right? So read the question properly, take some time to read, okay? And understand it, and take note of the chemicals and apparatus that you need, okay? So for example, if you want to test for hydrogen gas, you know that you are adding magnesium ribbon into acid, then you should know at the back of your mind, oh, acids plus metal will produce hydrogen gas and salt. So how to test for hydrogen gas is using lighted splint, and then it will give you a pop sound, right? It will extinguish and give you a pop sound. So if you know hydrogen gas, or rather you will expect hydrogen gas to be produced, you need to have your lighted splint ready and your Bunsen burner. Sorry, like your splint ready and also the Bunsen burner. Okay, right. So underline key information for the procedure of test, and then record readings to an appropriate number of decimal places and or significant figures. So for burette, it's usually 2 decimal places. Okay. Pipette is 1 decimal place. Okay. Now record all results and observations in an appropriate manner. Next, must know topics. Okay. So this topics always come up, okay, because they have a lot of things to test you in terms of experiments, okay. So for separation techniques, of course lah, this one definitely is under practical, but whether it is tested or not, then depends on the year itself, right? So be very well versed in these topics, especially acid, bases, and salts. QA, yes, QA, almost every year it comes out, right, Mr. Chu? Right? And then redox, reactivity series, not for redox. I'm not too sure whether it's every year, but I've seen it before, okay? And then chemical calculations is a very popular one, basically stoichiometry. So you need to be very well versed in it, okay? You must understand all these topics, okay? Very well before you go for your practical. Okay, next, possible experiments. Titration is the popular one, okay, because what else would they test you, right, other than titration? But I know for combined chem, I think titration is not included, right, Mr. Chu? No, right? Yeah. So this is what I know lah. For titration, combined chem, no titration. But for pure chem, yes. Okay, most often than not, yes, it will come out. Okay, it's one of the most popular topics lah. Okay, so first, if let's say the table is not given to you when it comes to titration, you need to draw the table. If it's not given to you, some prelim papers do not include the titration table and they expect the students to draw it themselves. Okay, so this is something that you have to look out for. Okay, right? So what do you need to do for titration? The table must include final burette reading, initial burette reading, and then volume of the said solution used. In this case, is Q. And then the best titration results is always within two titers within 0.2 centimeter cube. Okay, so it's either more or less, okay, plus or minus, right? So, and then you have to repeat 3 times, right? Okay, next, possible experiments. Okay, some years they have, or rather in prelim papers also, they have speed of reaction, okay? When there's speed of reaction, you know, it involves time taking, okay? Time taken and time taking will involve stopwatch, okay? So, you know, you need to know how to use your stopwatch, okay? And then experiments involving separation techniques such as paper chromatography, filtration, and distillation. Also, okay, for pure chem, salt preparation is one of the popular topics, okay? How to make salt, whether you precipitate, whether the salt is soluble or insoluble, that you have to memorize, okay? Remember your SPA table, that SPA solubility of salt table? I guess you need to memorize it at the back of your head, back of your hand, sorry. Okay, so for insoluble salt is usually you have to look up for white precipitate. Sorry, not white precipitate, just precipitate, right? Okay, not necessarily white, it can be other colors too, right? Okay, next, gas collection. For gas collection, how we can collect gas is by displacement of water using an inverted measuring cylinder or gas syringe, right? Next, organic chemistry reactions to write observation and draw general conclusions. So most often than not, organic chemistry they will not ask you to do it right then, like physical, practical. Rather, they will give you like a result table. Like they say, oh, we've done this. These are the results, and then you have to make your observations and also draw general conclusions. Okay. Right. Next. The next possible experiment is QA. Yes, this one is the most popular topic lah to be tested, right? Okay, so it whether if it involves element, compound, and mixture, like displacement reaction. Remember your displacement reaction for what do you call that? Metals, reactivity series of metals, and also halogens, right? So these two, metals and halogens, undergo displacement reaction. So this might come out, okay, might be tested. So it's something that you need to learn and memorize, okay, and be very familiar with it. Next is test for oxidizing and reducing agents. If you see a purple solution added to it, like potassium manganate, right, then you know that's an oxidizing agent, right? Or reducing agent is like potassium iodide, colorless solution. But they will, most often than not, they will write it up for you. Like, as in, like, they will mention that, hey, this is potassium manganate, this is potassium iodide. Okay. And then test for cations, anions, and gases as well. You need to know, it's already given to you, right, in the table. So you just need to be very wary of which gases are expected to come out, okay, or to be liberated. All right. So it is not required for you to carry out tests involving lead 2 plus ions, okay, or sulfur dioxide gas. It may be tested on reactions involving ions not included in the notes, okay, for QA. And please do not attempt tests other than those specified on substances except when it is appropriate to test for a gas, okay, because yeah, this is dangerous lah. Okay, so if it's not required of you to test that particular gas with I don't know, with a nitrate spleen or anything like that, don't do it. Okay. Okay. It might be very dangerous. Okay. Next. Oops. Sorry. So before you do, or rather when you are doing the question, before you carry out the experiment itself, especially when it comes to QA, please read first and then make short notes, okay, beside each test in pencil, okay. First, you have to add aqueous ammonia. Let's say, for example, it says here, add aqueous ammonia. You know, you are testing for a cation. So highlight that, okay, and then add a few drops of aqueous ammonia. Next, for example, test for, look, if it says dilute nitric acid with aqueous silver nitrate. Now, we need to know that we are testing for halides, halide ions, which is group 7 ions, right? To see what, if, then we have to expect, oh, what color would it come out? Whether it's, sorry, not purple, sorry, white or off-white, or yellow PPT, correct? Or if there's no visible change, then write down no visible change, no observable changes. So we know that halide ions are not present in that solution. Okay. Next, when you're adding reagents, please add it slowly, ensuring good mixture. And when you add slowly, add in small amounts first. Okay, until no further change is seen. Don't like dump everything one shot. No, cannot. You must do it slowly. Okay, so that you can observe the changes. Right. Next, if there is any lah, right? So the next one is write the observation beside each corresponding test. This is very important. Every time after you finish adding and then you observe, you write down observation. Don't wait until the final experiment. No lah, don't. Later you forget, right? So please write down the observation every time you finish the test, okay? Each test. Next, answers should include details of color changes and precipitate form. Now, I know some of you, I mean, most of us lah, can't tell between off-white and white, right? Whatever that is right to you, just write it down. It's based on your observation. If it appears white to you, or if, let's say, you really want to know the difference, you take your paper, right? Put it against, let's say, for example, you have the test tube. What you do is you just put a paper behind it, white paper behind it. If you're not given a white tile, if you're given a white tile, then put it against a white tile, okay? And if you see it's like white, just as white as a white tile, then put white, okay? If it's a bit yellowish, a bit tinted, then you write it as off-white. So yeah, you just use something very white as a background to compare, okay? Right. Next, if let's say, and name the test for any gases evolved, okay? Like for example, test for oxygen gas when aqueous hydrogen peroxide is used, okay? So whenever you see hydrogen peroxide, the decomposition of hydrogen peroxide is always oxygen gas lah produced, right? Or if acid is added to a solution and then you see effervescence, then you know carbonate ions are there. Then you know it's carbon dioxide, like that. So you have to test for the presence of that carbon dioxide gas with lime water, and it will turn chalky. And then you have to write it down. It is positive for carbon dioxide. Okay. Next, oops, sorry. This is one of the questions, that the part that a lot of students have trouble in lah. Okay, a lot of problems with it. Okay, so first, when it comes to drawing best fit line or curve, okay, independent variable is plotted on the x-axis. X-axis is like that, okay, if you forget. Now, for dependent variable is plotted as a y-axis. Now, Label the axis with units either temperature, degree Celsius, or time, right? Or volume, okay? Centimeter cube, right? Now, use appropriate scales such as 2 centimeters per 1 unit or 2 centimeter per 2 units, and not odd scales such as 2 centimeter to 3 for 3 units, which is quite difficult for you to plot later on. Okay, and then graph has to cover at least half of the graph paper. Yes, the bigger, the easier, the more stretched out it is, the easier for you to see. Okay, next, plot all readings obtained from your experiment and mark all points clearly and accurately with small or sharp crosses. So before you go into your practical exams, please make sure that you have your mechanical pencil or sharpen all your pencils, okay? Because you need to have sharp crosses. If not, it'll be too dull and it'll be too big. Then it won't be accurate. It will affect how your graph looks like, okay? When you're plotting the graph. Okay, next, of course, after plotting, you have to draw a smooth line, okay, or curve through all the plotted points. Do not join up the plotted points like jagged lines, okay, don't. Next, have equal number of points on each side of the line, okay, if you want to extrapolate it. Next, line or curve should pass through the middle of spaces between the points, and also for any point that is far from the best fit line or curve, repeat the measurement for the point. You need to repeat the measurement, okay, for the point and correct it, or circle the point to show that it is rejected, has been rejected, like an anomalous reading, okay. Next, identify the independent, dependent, and key control variables and draw a labeled diagram if required, and also include apparatus, quantities of reagents used if need to, okay, and measurements to make in your procedure, especially in planning, okay. So, we are doing planning now for pure chem. For planning, always remember that you need to know the independent and dependent and key control variables, and then draw a labeled diagram if you're required to do it. If they say, the question says, draw a diagram to further illustrate or further explain your answers. Then you draw it, okay? Then also include apparatus, quantities of reagents used, and measurements to make in your procedure. You may need to include a control setup too, right? Next, describe how the results could be used to address the aim and also suggest improvements or modifications. Okay. Is there a trick to remember those 4 triangles for chemical calculations? I always have trouble remembering them. Like mass over molar mass gives you moles. Is that the one that you are asking? Yes. The trick to remember is to keep on looking at your notes lah, and then keep on memorizing it. That's the trick. It won't take long. It will take about 5 to 10 minutes to memorize the triangles. Oh, sorry. Don't look at just the triangles. Look at the formula and understand first how the formula works. Then only you look at the triangles and memorize it. Okay? So that's the trick to remember for me lah. That's why I always tell my students. You must understand first. Okay? Right? Next. After you suggest improvement, okay, this is an example, okay, of a planning question. Okay, so a student decides to investigate the effect of concentration, right, of aqueous potassium manganate on the rate of its reaction with acidified hydrogen peroxide and whatnot. Okay, and the student will determine the rate of reaction by collecting the gas produced. Okay, so in this question, right, the concentration of C, which is aqueous potassium manganate, okay, the concentration will affect the rate of its reaction. How? By determining, or rather it will be determined by the collection of the gas produced or the gas produced. The amount of gas produced will tell us the concentration of aqueous potassium manganate. Okay. Okay, so in this question, we need to list down what are the independent and dependent variables are. Okay, so for independent variable, it's basically the concentration of C and also aqueous potassium manganate. Okay. Next, the dependent variable is the time taken or the volume of gas produced. So if let's say Why is it time taken or volume of gas produced? It's given the same time taken. I say you limit the experiment to 5 minutes. Within that 5 minutes, how much gas will be produced? How much volume of gas will be produced based on the concentration? Or, or how long does it take to collect 20 centimeter cube of gas? So produce. So basically, it depends on whether at the end of the day, you want the time to be the limit or the volume of gas to be the limit, right? So let's say if let's say the experiment says, you want to plan the experiment by collecting the amount of gas at 20 centimeter cube, right? Then how long will it take to collect 20 centimeter cube at 5 moles per dm cube, at 10 moles per dm cube, at different concentration? So at different concentration will affect the time taken for that 20 centimeter cube of gas to be collected, okay? So how do we collect the gas? Of course, we use gas syringe, okay? So that's the most popular way to collect gases produced during reaction. Okay, so I hope, I know it's a very short part for me. Yes, thank you so much. If you have any other questions, please put it in the chat. Mr. Chu, are you okay with this? Do you have anything else to say?
If you have any question, just put in the chat. I hope this session has been helpful for you. I think it's more about setting an expectation for the exam and knowing what is going to come out. I mean, we will not know what are the topics that will come out. Basically
Mm-hmm.
all topics will be tested, but we do not
Mm-hmm.
know how much they want to test you. Okay, like I
Correct.
said just now during the topic analysis, right? There are
Mm-hmm.
some years one topic can be just a few marks, but another year they can test you more than 10 marks. Okay, so these are just to set the expectation, which also means that you have to revise for all your topics. You need to be very ready for the exam. Cannot choose your topic to study. But of course, there are some topics that you can emphasize more, such as those topics that we mentioned that are more challenging, that also you all face difficulty in, electrolysis, organic chemistry, calculation. These are the major players in the test. Okay, so make sure you practice sufficient enough for the exam. Okay, and my straighter teachers are always ready for you, always for your questions. Okay, so if there are no further questions,
Right.
thanks so much once again for joining us last week and this week. Okay, upcoming we have chemistry boot camp. Okay, so do look out for it, and yeah, we'll be revising some of the topics, going through the questions. All right, so please join us if you need a final push. That is the one for you. Okay. All right.
Okay.
Thank you so much.